Okay, I see Sarah also has joined. Where is Neil? Okay. All right. So let me set the context. What we will learn today, this is the last unit of SAT prep syllabus that you see on Khan Academy. Hey, Neil. So I'm not saying that we are done. What I'm saying is we are done with one iteration. So some of you who has joined in between, yes, Sahit. So we'll go through this unit, which is on advanced trigonometry and geometry. Hello, Ritika. And then after that we'll go in the next loop. So you guys are stuck in a loop with me. What that means is we will cover all the 13 units that we have to prepare for SAT in as many iterations as possible. And every time we come across any unit that we have covered in the past, some of you might feel that we are again doing the same thing. But the way I look at it is, it becomes an opportunity for us to revise what we know or reassess our own understanding of things. Okay, so when you see me doing the same unit over and over again, the idea is simple. Math is about practice, and every time we come back to a unit, it is for us to do a quick check of our own understanding of things, how much we remember, how much we forgot, what technique we are able to apply, what technique we are missing. Okay? Hello, Yasmita.
Hi, good afternoon.
Good afternoon, Beta. So we are starting the 13th unit of SAT prep, which is advanced trigonometry and geometry. So we'll start with geometry and then we'll go to trigonometry. Okay? Hi Ritika. Can you hear me okay, Beta? I saw you dropping and joining a couple of times.
I couldn't hear earlier, but I can hear now.
Okay. And can you guys see the full board? Okay. So we are starting with advanced geometry. And I will not ask you what is advanced geometry. Whatever we know with respect to geometry, we will go to the next level of it and see what we know versus what we don't, and how do we bridge any gap that we see with respect to our understanding. So as part of this unit, we are starting with the 3D objects. And when I say 3D objects is something that I cannot draw on this board. This board is two-dimensional. It has horizontal axis and a vertical axis. That's it. So we have an X and a Y. So how do we learn 3D objects? There's a Z axis or Z axis that you can see when I'm moving my hand towards you guys. So when we talk about 3D objects, essentially we are talking about X, Y and Z axis. And you must be thinking that, okay, are we talking about three-dimensional? Hello, Ananya. So we just started. Now nobody has missed anything. So we're starting with this unit, which is advanced geometry and trigonometry. And this is where we're starting with geometry and then we'll go to trigonometry in near future. Yes, Ananya. So as part of this unit, I had sent a message saying what all we are going to cover. So we are going to talk about 3D objects, primarily around volume and surface area of different objects, and then we will look at some of the different interesting techniques for dealing with those. Now let's do a quick check. Everybody clear? When I say 3D objects, nobody has any doubt in their mind, right? It is like something which has length, width and height also. If you look at my phone right now, what you are seeing is pretty much like a rectangle. It has, let's say if I put it this way, this is the length, this is the width. That's what you are seeing. And it could be as simple as like a piece of paper. But when I flip it a little bit, now you are seeing that, okay, it doesn't only have length and width, it has height also. I mean, not much, but still there is a height, right? So when we talk about 3D objects, we talk with respect to length, width and height. Look at my water bottle. It is looking like a circle right now. If I flip it a little bit, you see that there are so many circles stacked one after another to give it a height. Similarly, if I take Praneeth's notebook, you guys can see this is length and width only, a rectangle. But when there are so many pages tagged one after another, you are not only seeing length and width, you are also seeing height. So that will be our premise for looking at any 3D object. Meaning a 3D object could be something which has length, width and height, or it has dimension along a flat surface and the height next to it. Now let's look at some quick shapes. And this is a square. It became a cube. Now, certain things that you would keep in mind is when you look at square, you're essentially talking about length and width being the same. Here, in case of a cube, your length, your width, and your length, width, and this is your height. If your length, width, and height all are same, length equal to width equal to height, that is when it qualifies to be called as a cube. Yeah. If it is not the case, meaning you are talking about a rectangle being extended further, we are talking about a cuboid, where the length, width and height are very different from each other. Okay. So length, width and height, we don't have a compulsion for having them same. I mean, if they are the same, we don't mind, but underlying idea is that they need not be same. Okay. So that's the first difference between cube and a cuboid. And I'm pretty sure you guys all know about it. I'm probably boring you guys a little bit right now. But the intent here is, I'm just trying to make sure that the basics stick with us. Hello, Vishwa. So far, everybody okay? Nothing new, nothing surprising, nothing bothering. Okay. Now, this is just, we have just looked at the properties. That okay, this is cube, this is cuboid, length, width, height, all same. We will call it a cube. Length, width, height, we don't have a compulsion for having them same. If they are the same, we don't mind, but they're not same. I mean, they're not same. If they're same, why would we use a new term called cuboid? If they're same, then cube. If they're not same, cuboid. Here, your base of this shape is a square. You're extending your square in a vertical direction. You're giving height to it, and then you're being careful about the fact that your height is same as your length and width, or any other side. That's a cube. Here, you have a rectangle. You took a rectangle and you extended it further. Like I showed you guys, Praneeth's notebook, where I was showing you one page, and then if you keep on stacking one after another page on the top of that, add more thickness to it, that's when it is a cuboid, conceptually. Now, you all see circles. If this circle, if I keep stacking one after another, after another, after another in a vertical direction, and I keep adding height to it, this is called right cylinder. Everybody with me so far?
Yes, sir.
Okay. So this is, so what I was trying to emphasize so far was that if you're looking at a cube, you're talking about a square as a base, adding height to it. If you're looking at a cuboid, you're looking at a rectangle as a base, adding height to it. If you're looking at a right cylinder, you're looking at a circle as a base and then adding height to it. Meaning, symmetric shapes, one after another, you're stacking on the top of that. So if I ever dare to say that this is a right cylinder, you will say no. Because though it gives a bit of feeling that it's a right cylinder, but it's not very much symmetric. Here it has got thinner. So if you look at the circle here, that circle is smaller than the circle at the base. So this is not the right example of a right cylinder, but if you visualize that, okay, I'm talking about the shape only till here, this might resemble with a right cylinder. Yeah? So far okay? So when we talk about any two-dimensional shape, let's look at the father of this, which is a square. Let's look at the father of this, which is a rectangle. And let's look at the father of this, which is a circle. Whenever we talk about these shapes, which is the base of these objects, we are talking about two dimensions. What are the, you know that, okay, if I'm talking about a square, I'm talking about all sides being same. Every angle being 90 degrees. Opposite sides being parallel to each other. If I'm looking at a rectangle, I'm talking about opposite sides being equal and parallel to each other and every angle being 90 degrees. If I'm talking about a circle, I'm talking about the property where every point on the border of the circle is equidistant from a place called center. And this distance is radius. These are the properties we know. If you extend further to the property, what additional thing I know or I want to know about these shapes, you will say, okay, area and perimeter. What is the area of a square? Length is square. What is the area of a rectangle? Length times width. What is the area of a circle? Pi r square. If I am talking about perimeter, what is the perimeter? 4 times the length. 2 times the length plus width. 2 pi r. This is the base, okay? So I have not started building my house. I have just talked about the base of the house. Now let's look at the next thing. So these things are history. We are going beyond history and we are looking at the present. So when you look at 3D objects, there are two more things that comes into play. One is called volume and one is called surface area. Any 3D object's volume, if you're talking about, in the simplest possible way, you will say that, Yarush, everybody can hear me okay, right? Okay. So Pranit is the only one. Even if he says I cannot, I will not believe him. But for rest of you, I would rely on what you guys say, okay? So we are talking about 3D objects, kids who have joined a little late or who are trying to figure out what blabbering I'm doing right now. We are talking about 3D objects. And we just touched upon what is the base of these objects and what are the properties of the base objects. Now we are coming to the 3D objects. This is the cube, cuboid and the right cylinder. And we are saying, okay, how about what are the additional properties that comes into play? We know that, okay, you have a base and you have a height. What are the extra properties that we need to be aware of? One is called volume and second one is called surface area. Now, before I go into the mathematical part of it, when you say volume, what do we mean?
The amount of space an object takes.
The amount of space that an object takes. If you're talking about a cube, you'll find out how much space that it needs. So that if you have to put X number of cubes in this classroom, if you know the volume of every cube and you know how much space we have in this classroom, you can figure out whether you can fit in 50 cubes of this size, or you can fit in 5,000 cubes, or you can fit 2 million cubes, okay, in this classroom. Now comes surface area. What do we mean by surface area? In the simplest possible way. Let me see if somebody wants to say that on the screen also. Pranit is ready, but I want to give everybody a chance. Yasmita, Sahid, Sara, Neil, Samriti, Ritika. Anybody wants to say what is the surface area? Yep, Ananya, go ahead.
Like the surface of like.
Okay.
Not the void, like the surface.
Surface, okay. Dave?
Like the usable area that can interact with another shape.
Okay. Interact with something else, okay? Yeah.
All the area of all the faces on the 3D object.
Right. So now, yeah, Vishwa, go ahead.
The area that kind of outlines it, the kind of like an outer layer.
Outer layer. Now let me give you guys the lamest example ever. If we are talking about a volume, let's take me as a 3D object. What will be my volume? Will be the space I would need. can you fit me in this box where I'm keeping, if you guys cannot see it, can you guys fit me in this box where I'm keeping my markers and the dry eraser? Is determined by the volume. What is my volume and how much space I have here. If you want to know what is my surface area as a 3D object, that will be determined by how much paint you would need for coloring me green. Okay. If you guys are tired of seeing me the same way all the time, and if you want me to color me into something which makes me more reasonable or acceptable as a teacher, let's say you want to color me blue. So then the amount of paint that you would need, meaning how much of my entire body surface that is exposed. Obviously you don't want to cut me open and then color my inner part also. But on the surface, whatever is visible from outside, that is what is surface area. I know that was probably not a very interesting way to describe it, but at least you will be able to relate. Okay. So how much space I take is my volume. How much of my surface that is exposed to outside world is my surface area. Now let's look at these objects, and there are a few more to it. I am not going to stop here and say this is it. So let's start from the cube. What is the volume of a cube? Okay. I have an answer already, but just to set the expectation right, your volume, how much volume it is determined by how much is the area of the base multiplied by the height. Okay? We'll take that as a underlying principle and then see what is the volume of my cube. Will be area of the base, which is length times width. My length and width are both same in case of a cube, into the height. Again, my height, length and width all are same. So this is length cube. Okay. I'm just deriving the formulas quickly by relating to the basic concepts, and then we'll look at some interesting problems to deal with. Yasmita, Neil, Sarah, everybody with me so far? Sahit, Nanya, everybody?
Yes, sir.
Okay. Okay. Yasmita, okay, beta? Alright. So volume is this. What will be my surface area of a cube?
Length squared times 6.
So what Praneeth is saying is, when all of the length, width, height all are same, so we are seeing actually 6 squares of the same size on 6 surfaces. One that you see here, I'm just coloring a corner of it so that you can visualize it. Second is on the top. Third one is on the opposite of this, on the back. This one, front and the back, top and the bottom, side and the opposite, one opposite to that. And everybody is same. Length and width and height, all the dimensions are same. So it will be 6 times area of one of the side, which will be length into length. 6 times L square. This one is okay so far? Is everybody with me? If anybody has played snakes and ladders, I always mess up the pronunciation of snacks and snakes. Okay. So if you guys have played snakes and ladders, okay. So you would have seen the dice that you roll, and then you would see that okay, 1 to 6 you have written on each side. So and every side is of same sides. Every side has same area, and that is why it is 6 times L square. Just a practical example. Now if you're talking about a okay, so the kids are alright. If you're talking about a cuboid, what will be the volume of that? Anybody? Anybody? I don't want to teach this. I think you guys already know it. That's why I'm bothering you guys to answer this for me. What will be the volume of a cuboid? Anybody? Yes, Arush.
Isn't it the same as a cube?
Yeah, I mean, it will not be length cube. In the case of a cube, your length, width and height are all same. Here, that is not the case. They'll be different. But our approach will remain the same. Take out the area of the base and multiply that with the height. Area of the base is length times width and then times height. So volume will be length times width times height. In case of a cube, we saw that length, width and height are all the same. Here it is different, so it's length times width times height. What is the surface area? Yeah. What is the surface area of this one? And again, I'm just poking you guys to visualize this, okay? There's nothing tricky about it. I am pretty sure you guys all know about it. You would not remember the formula. You don't have to remember the formula. But look at the things. Opposite sides, front and the back are same. This side and upper to that is same. Top and the bottom are the same. So let's find out the area of this side. I'll multiply that by 2. Let's find out the area of the top. I'll multiply that by 2. Let's find out the area of the side. Multiply that by 2. If this is length, this is width and this is height. Area of the front is length into height. Length into height. Multiply that by 2. Plus, look at the top. Here length and width. Length into width. Multiplied by 2. If you look at the side, this is width and this is height. So W into H. 2 times length into H, length into height plus length into width plus width into height. That is what will be your formula for surface area. And again, you don't have to memorize this. As long as you are able to make the worst possible or the simplest possible drawing. If your drawing skills are as bad as mine, you will still be able to visualize this. That okay. I'm talking about surface area, meaning the front and the back, same. This side and this side, same. Top and the bottom, same. So find out this area, multiply by 2. Find out this area, multiply by 2. Find out this area, multiply by 2. If I'm giving this as length, this is width and this is height. When I'm looking at this side, this is a rectangle with this as one side and this other side. Length into width. This is not width, this is height. So length into height. If I look at this rectangle, this side is width, this side is height. So width into height. If I look at this rectangle at the top, this side and this side. This is length and this side is width. So length into width. So 2 times of length into width plus width into height plus length into height. And I request you guys not to memorize this. Just apply your visual skills. With minimal drawing, you'll be able to figure it out. Is that okay? Everybody okay so far? Ananyas, Ritika, Vishwa, Yasmita, Vishal, everybody okay? Okay. So we looked at what are 3D objects, what are commonly used 3D objects like a cube, cuboid and a rectangle, right cylinder. We looked at what do we mean by surface area and volume of any object, and we tried relating that to derive the surface area and volume for a cube and the cuboid. Now we are coming to a right cylinder. This one I would want you guys to break your head a little bit and help me find out what will be the volume and surface area of a right cylinder. Everybody is clear what is right cylinder, right? So help me find this out, okay? I don't want to teach everything to you guys. I want you guys to teach me some things as well. Yep. Yep. Wonderful. Who will tell me what is the volume of a right cylinder? This is my right cylinder. Let me give you all the clues, all the details that you would need. This is my right cylinder. and this is the radius of the base, which is a circle, and this is the height r. What will be the volume? Same concept. Find out the area of the base, which you guys know, pi r square. Multiply that by the height. This is your volume, pi r square h. Yeah. Now surface area. What do you see with respect to surface area? You see this side of the circle that is visible. Look at this as a right cylinder, okay? Yeah. Oh, thank you. Pranit has seen me so many times. This is a right cylinder, okay? Here what you are seeing is a circle. This is one side of the surface. This is another surface, and then this curve that you see. So you will say, okay, fine. If I'm talking about surface area, I'm talking about this shaded circle and this shaded circle, because these are two surfaces that is visible from outside. So 2 times pi r square. This is pi r square, this is pi r square. Now this curve, this is interesting. How much? So if I find this area, which is pi r square, this area which is pi r square, and then this area of the curve, that will be my total surface area of the right cylinder. So pi r square plus pi r square, 2 pi r square, that we have found. Now we are trying to find out the area of the curve. What I did was, this cylinder that I had, this right cylinder that I had, I cut it open, and that became a rectangle. So this length into this length, if I multiply them, that will be the area of my curve. But how much are each length? One of the length is the height, which is opening and giving you one side of the rectangle. Other length that you see of the rectangle is nothing but the perimeter. The perimeter of the circle is opening up and becoming one side of the rectangle. How much is the perimeter of a circle? You guys remember? So this one that we got by opening it up, one side is this one, the perimeter opened, okay? And this is the height anyways. What is the length of this perimeter of a circle? If you know the radius is r, if you know your radius is r, if you know the radius is r, this whole length is 2 pi r. So this length is 2 pi r. Now look at this length and this length. Length times width. 2 pi r times width. That becomes your total surface area of a right cylinder. So 2 pi r square plus 2 pi r h. Or if you want to make it a little shorter, 2 pi r is common in both the terms. So here r plus h. 2 pi r into r plus h. Any which way. But is everybody clear about it? I'm sure most of you would be knowing about it. I just decoded that. I just tried simplifying that. And if somebody was knowing it, I just helped you guys revise it. Are you all okay so far? Samriddhi, Yasmita, Nanya, Arush, Ritika, Vishwa, Neil, Sara, Vishal, everybody? Everybody okay so far? Sahit, okay? Saranya, okay? Tanya, not okay? Now, if you guys don't tell me, that shakes my confidence. That's why I keep bugging you guys, okay? Ritika, okay, beta? Okay. So we just saw some of the basic shapes, basic 3D objects like cube, cuboid and right cylinder, and we looked at how the area and volume formulas came into existence. What is the underlying principle which helps us do that? Now let's look at one more shape which I will call as cone. And if you look at it, we had a right cylinder before, we just cut two sides away. I mean, it might look like this is half and these two are half, but actually if you visualize that as a 3D object, it's actually 1/3. So you are looking at front end view of this one, but these two are like, it's making like, if I this what you're seeing from the, if you're seeing it from the top, you're only seeing this one like this, okay, and these two sides again when they combine and when you rotate them, right, this will make other two cones, okay. So basically this, whatever is the volume of one right cylinder, you should divide that by 3, one side this one side this one. If you look at carefully, right, these two will combine. This is 60 degree, this is 60 degree, 120, this is 120 degree. I mean, I'm just trying to help you guys visualize this, okay. So these two portions that you see on the side consumes 1/3 of the volume of a right cylinder as well. So volume of right cylinder of a cone is 1/3 the volume of a right cylinder. Okay, I'm just giving you as just the formula for now, and we'll deal with more problems as we go into detail of it. But is that okay so far? Okay, and there's one formula, there's only one formula that I will request you guys to memorize, that is, if you have a sphere, like a ball, what is the volume of that guy? It's a radius r. What is the volume of a sphere, if you guys remember? It's 4/3 pi r cube. And if you ask me why, I will not bother to explain that to you guys or explain that to you. It needs a lot of calculus techniques for deriving it. And I have not taught you guys calculus so far. I will not jump onto it to make it complicated for you guys. But for now, you'll have to just memorize this formula for the sake of being ready to deal with any problem with volume. Okay. Now, is it 4/3 pi r cube? Yeah, it is 4/3 pi r cube. Yep. Yeah.
So what would be the surface?
It's 4/3. Yeah. What is the surface area? Do you remember?
No.
I think 4/3 pi r square, if I'm not wrong. But let's park that. Let's deal with some real problems. Okay. It's not just about me telling you guys concept after concept and we don't see the application of it. But before I move on to dealing with some problems for you guys, a quick question. Whatever I have talked about so far, is that part clear, or did that help you guys recall what you already knew? Okay. Let's move on to some real problems. Otherwise, it will just remain a problem. Before we jump into some problems, right? There's some basic things that we need to be aware of. Let's say if I give you guys some stupid problems to deal with. Let's say I have a 3D object. It's a 3D object, right? Though it's not very symmetric. I'm saying, can you guys find out the volume of this guy? I'll give you a bucket, a measuring bucket where you would know if I'm filling water or liquid till a certain level, how much volume it has taken. And then some water, obviously water is there, and I'll give you the object and say, okay, fine. Can you find out the volume of this object? Yeah.
So we would just put, how much water there already is inside of there,
Mhm.
or how much it is. Once you put it in, you can measure how much of the water rose, and then how much it rose by is the volume of that, because
Okay.
the volume of that plus the
It took that much space and added to it.
space.
Okay. So what Pradeep is saying is that if as a teacher I try to find out a formula for deriving volume of this guy, let's say I spend 2 more years to come up with the formula, then there will be another object that will be given to me and I'll be asked to find out the volume of that. Say, okay, find out the volume of this marker, and then I'll take another 3 more years. By the time I find out the formula for this guy and this guy, I'll either have no hair, or if I still have hair, there'll be no black hair left. Okay? So we are certainly not wanting to do that. There's an easier way of doing it, and that is by, like what Pradeep was explaining me was, let's say this is a bucket of water, okay? And as you can see, there are some measurements here. It says, okay, 22 ounce, 38 ounce. I mean, if I'm taking a bigger bucket and bigger object to measure the volume for, I will put water till, let's say, a certain level, and I would know, okay, how much volume of water I have in this can, and then dip that object completely inside the water and see what is the new measurement of the water level. And whatever is the difference, that is the volume of the object that I was trying to measure. I don't really have to waste my 4 more precious years to find out the formula for that. Not every volume that we have to derive is to be derived using a formula. As long as, that's why we focused on the volume of the basic shapes like cuboid, cube, right cylinder, cone, whatnot, sphere. We'll take that as a base, and anything non-symmetric or unique or something that for which we don't have a formula, we can still find out the volume for those, and that's what scientists do. If they have to find out the volume of any object, they'll say, okay, fine, I have a measuring flask, I'll fill water to a certain level, dip that object completely and see how much water it displaces, meaning what is the rise in the volume measurement, and that difference is the volume of the object, because every object, when you dip in water or liquid or even in air, it displaces that much amount of water or the medium in which it is submerged. Okay? Does that make sense? Or I'm just bothering you guys like always? Everybody okay so far? Okay. Vishal, Dev, Ritika, Vishwa, Neil, everybody okay? Alright. So we just looked at some of the basic principles or the understanding that we have to have for dealing with 3D objects and the volume, and now we are actually putting ourselves inside that rigor to solve some realistic problems, okay? Not a problem that I am cooking up. So now let's look at the first problem. This problem is, if you rely on my drawing skills, this is a cone, inverted cone, which says 4 centimeter from here to here, and this is given as 10 centimeter. Now I'm reading the question for you guys. An ice cream cone maker wants to build a more stable cone by increasing the diameter and decreasing the height of the cone. An ice cream cone maker wants to build a more stable cone by increasing the diameter and decreasing the height. So increasing the diameter, meaning make it wider, and reduce the height. Obviously it's an ice cream cone maker, right? He doesn't want to give a lot of ice cream to us. So he's trying to build a more stable cone by increasing the diameter and decreasing the height of the cone. Okay, so right now focus is making it stable rather than saving money. The cone currently has diameter of 4 centimeters and the height 10 centimeters as shown. They want the height of the new cone to be 8 centimeters. So the new cone that gets developed or built, the height of that will be 8 centimeters. Which of the following is closest to the smallest radius of the new cone he can have? New cone. Okay. Which of the following is the closest to the smallest radius the new cone can have, so that the volume is at least the volume of the old cone? Meaning, this is the cone with 4 centimeter diameter and 10 centimeter height. Says the ice cream cone maker wants to reduce the height and increase the diameter so that the new cone has at least the same volume as this one. Meaning, the best scenario that we have to find out is the volume of this guy is same as the volume of this guy, as close as possible to this guy. Okay, it cannot be less than that. And the options given are, it says, which of the following is the closest to the smallest radius the new cone can have? Smallest radius that the new cone can have, at least so that the volume is at least the volume of the cone, of the old cone. And the options given are 2 centimeter, 2.3 centimeter, C is 4.5 centimeter, D is 5 centimeter. Did everybody get the question? So this is the cone, dimensions given. He's trying to make it shorter and wider. It says the new cone's height is 8 centimeters. Find out what is the diameter of the new cone so that the volume of this cone and this cone is the same. It says at least the same, meaning you have to just match the volume. Obviously, you don't want to disappoint your customers by giving them less ice cream in the cone. Everybody got the question? Ananya, Arush, Samriddhi, Sahit, everybody? Ritika, Vishwa, Neil, Sara, everybody? Alright. So help me find out the answer for this one. And it's just been little while when we looked at the volume of the cone, which is 1/3 of the volume of a right cylinder. I'll let you guys deal with this problem. I'll take a minute maybe to fill my water bottle. So is everybody giving it a try? Okay.
Are we supposed to find the radius or diameter?
It says find out the radius. That's why I was stressing on that word radius. Let me read it for you guys one more time, okay? It says, which of the following is closest to the smallest radius the new cone can have, so that the volume is at least the volume of the old cone? Yeah? Yes, Nanya.
The radius is 2.
Radius is 2 of the new cone.
Yeah.
Not trying to challenge you better, but I'm making you think. See, right now if you look at this guy, the radius is already 2 centimeters. Okay? And this is the height. So pi r square into height, whatever it be, okay? I'm just giving you reason to think about it, okay? Now when you reduce the height, when you're reducing the height, that means look at inflating a balloon. Let's say not inflating or deflating rather. A balloon is like this tall. Imagine my face being the balloon. Okay? If you are reducing the height, meaning you are squeezing it from the top. If you are squeezing it from the top, what will happen is my length of my face is reducing. This will expand in this direction. So your radius will increase for sure. Okay? How much that is? I don't know. That I'll let you guys calculate. But when I'm reducing the height, I'm kind of squeezing it and trying to fit in the same amount in a lesser height. That means it will become wider. Meaning radius will be more than 2 for sure, because here your radius is already 2. Am I giving you a reason to think better? Everybody makes, is it making sense to everybody? Okay. You got B. Okay, Pranay got B. I would not contest him straight away, because I see that okay, whatever it was the case, it was 2 centimeters, it is a little more than that. I'm not saying that this is the right answer, but I'll still say okay, fine, review it while every other friend is doing it. But at least this one is ruled out, actually, that's what I'm trying to say. I'm ruling it out immediately, because if my current radius is 2 centimeters and height is reducing, that means it is able to expand horizontally. So it will be more than 2. So this is ruled out. So you guys have 3 options to choose from, depending on what your calculation says. Ananya, I just sat down on the chair, that's why you're not able to see me. But I did not disappear after telling you something, okay? Alright. So think about it, everybody. Everybody. I'll give you guys maybe 2 more minutes before I jump onto it. Samriddhi, Sahit, Arush, Vishwa, Saranya, everybody, okay? And I'm just calling some names. That doesn't mean some people are exempted.
Do we have to find the radius or the diameter?
Radius.
Okay, then I think it's B.
It's B, okay.
I got
Yes, Samriddhi.
I got B.
You also got B. Okay. So I heard B from 3 of you. How about Arush, Sahid, Ritika, Nikhil? Yeah, Nikhil, go ahead.
I got B too.
You also got B. So, B is quite positive. We want to be positive, but we would check. Okay? Because of my problem, not anybody else's. I don't trust anybody. And I'm spreading that as a disease to y'all. You're saying something?
Do you want me to explain how?
Yeah, go ahead.
Okay, so I decided to, if we're gonna find out if we want the same volume as both of them, we already have the measurements for the first cone, so I used that to find the measurements of the volume of the first cone, which turned out to be about 41.83. About. And I said I gave this, and then I used the second cone's height and set R to X, and then set it equal to 41.83, and then I isolated X, which got me to the square root of 5, which is roughly about 2.3.
Okay.
And 2.3 squared is 5.29. So.
Okay. So that was Pranit's approach, and I'm pretty sure you guys all do the same way. Now let me show you a more playful approach here. So first thing is, can I assume that I have everybody's attention right now? Everybody with me? Okay. Arush, Sahib, Sarah, Neil, everybody? Okay. Now, one thing that I keep kind of prescribing or trying in the class is, we don't necessarily have to solve for each problem. One of the technique is, we can always look at possible ways to eliminate unwanted options. Okay? So if we are able to remove or eliminate unwanted options, that gets us closer to the right option. So first thing we did was, looked at this 4 centimeters the diameter, that is 2 centimeters radius. I will sit down as if you are not here. You are 8 minutes early for the class. And no sound at all. Okay? So, 2 centimeters by radius. Now, reducing the height, my width will increase because my volume is going to remain the same. So, 2 centimeter option is ruled out. So, this is my first technique for ruling out an unwanted option. You sit down without you being here. So, you are not here. I don't want to hear when a pin dropping. I don't want to hear a sound even of a pin dropping. So you're not here, I'm not talking to you even. Okay, so this one is ruled out. Now let's say, okay, we have to find out what is the radius. Let's say R is the radius. So now look, this volume and this volume has to be same. So 1 by 3 pi into R cube. 1 by 3 pi r cube h. H is here 8 centimeter. This volume is equal to this volume. 1 by 3 pi r cube is 2 cube. 2 into 2 into 2 into h.
It's not cube, it's square.
My bad. Thank you. Yeah, my bad. I got a little emotional with the problem. So here, this side 1 by 3 I can knock off. This pi I want to knock off. This 2 squared, now I squared into 8 equal to 2 squared, that is 4 into 10. 10 I can write as 2 into 5. So this 4 into 2 becomes 8 and you have 8 here. Divide both sides by 8, it becomes r squared equal to 5. That means r equal to square root of 5. Okay? This is certainly not an option. This is already ruled out. 4.5 square. 4 square itself is 16. 4.5 square cannot be 5 for sure. This is the only legitimate option that we are left with. So I'm not even bothering to calculate. I am eliminating the unnecessary options. Did that make sense to everybody? Yeah? So, again, I'm kind of contradicting myself most of the times. I'm saying that we have to learn how to solve a problem, and then once I tell you guys the technique, then I'm saying, okay, let's find out ways not to solve it. There's a very thin balance that we have to strike between these two. We have to know the concept, we have to know how to calculate, but when it comes to solve it during the exam, we have to find out what all we can find out without putting much solution to it, where we can eliminate the options so that our calculation becomes faster. See, square root of 5, you can say, okay, 2 into 2 is 4, so okay, let me see, 2.1 into 2.1 is 4 point something, and then 2.2, okay, maybe 2.3. I'm saying don't even go there. You can use a calculator to find it out. I'm saying we don't even need that calculators right now. Just basic techniques or some common, what you call, thoughts will help you eliminate the unnecessary options. Does that make sense? Everybody? So we have 3 more minutes before I let you guys go. But what I will do is, I'll just read a question and see how easy or relatable that sounds to you guys when it comes to solving it with an approach. Or how do you derive an approach for solving this kind of problem? I'm reading the question for you guys, okay? A cylinder and cone have equal volume. A cylinder and a cone have equal volume. Volumes and radii, R-A-D-I-I, how do you pronounce it? Radii? Huh? Radii, yeah. So a cylinder and a cone have equal volumes and let's say common radius, same radius, okay? If the height of the cone is 24 centimeters, then what is the height of the cylinder in centimeters? Sit down as if you're not here yet. Okay?
I guess we don't need.
We're not here yet. There's another class going on for next 2 minutes. A cylinder and a cone have equal volumes and radius of equal length. If the height of the cone is 24 centimeters, what is the height of the cylinder in centimeters? So here's the thing. This is the cylinder. This is the cone. It says both have same volume. What is the volume of this guy? Let's say this has a radius, this has. It says volume and radius are same. This guy's radius are same. Volume is also same. What is the volume for this guy? 1 by, this is pi r square into h. Here what is the volume? 1 by 3 pi r square h. Says radius are same, so both are same. I don't have to worry about it. It says volume of the cylinder is 24 centimeters. Sorry, height of the cylinder is 24 centimeters. What is the height of the cone? Pi, same. This height will be equal to, this goes to this side. 24 to 3. Yeah? Does that make sense to everybody? And this is some of the very normal problem that you guys will deal with in your exam for ICT. I just gave another example. What we'll do is, in the next class, which is on next Saturday, the class that we have on Wednesday for as a makeup class, we'll look at some trigonometry concepts, okay? So, we'll continue with the volume, the geometry part in the next class. Trigonometry basics will catch up in the next class on Wednesday evening. And then after we finish the geometry, then we'll go to trigonometry. So that way, there's no break for us and we are not angry with the teacher because there was no class yesterday. Alright? With that being said, I will let you guys know. Yes, Ananya, tell me better.